Hi everyone. Today we are going to talk about converting infix to prefix expression. This is one of the stack application that we have seen. We have already discussed how to convert infix to postfix and how to evaluate the postfix expression. In all these conversions we are using stack. Now we will see that how we can convert any infix expression to prefix expression. So let's see the algorithm. So for converting infix to prefix, we have two methods to achieve this. So we'll see one by one. This is the first method. As we have already discussed the algorithm for converting infix to postfix. So the algorithm for converting infix to prefix is also very similar to postfix. Only we need to take care of few things that I am going to tell you. So let's start. The very first step is push this right parenthesis onto the stack and add the left at the start of A. In the postfix evaluation, what we did just opposite to it, in that we put the right parenthesis at the end of the expression and left parenthesis we have pushed into the stack. But here what we are doing, we are pushing the right into the stack and adding the left at the start of the expression. Then we need to scan the entire expression. In the previous case, when we are converting to postfix, we are scanning from left to right, but in the prefix we will scan from right to left. So we will scan all the characters which are there in the expression, and then we perform the following steps. Now in the expression you may come across either the operands, which may be the digits which are giving in the expression. You may come across the operands, operator, and the brackets. So what we have to do when we come across these symbols, so if you come across operand, you need to simply add this to the expression that we are getting as a result. So we are calling it as a B expression. The A expression is the expression which is given to us, which is we are calling as an infix expression, and we are converting this infix to expression V, which is going to be prefix expression. So if you encountered any operand, you simply add it to the B. If a right parenthesis is encountered, so if you come across the right parenthesis, you need to simply push onto the stack. So whenever you come across right parenthesis, we simply push on the stack, or you can see here we have started with the right parenthesis on the stack. Okay. So if you look into any operator, you need to look into the stack, and if you find any operator which is of higher precedence, then you have to pop that operator and add it to the B. Now keep in mind, this is something different in the case of postfix. In the postfix, we are looking for any operator of the same precedence and the higher precedence. Then only you are popping, you are doing the pop operation and adding to the stack. This we are doing in the postfix. But in the prefix, we will only pop the operator if the operator which is in the stack is of higher precedence. This we are doing in the prefix. So this is something very important that you have to keep in mind while converting from infix to prefix. If you encounter the left parenthesis, then you have to repeatedly uh, pop from the stack all the operators which you see until you encounter the right parenthesis. And once you encounter the right parenthesis, you stop, and also you will remove this right parenthesis from the stack. So this will be remove the right parenthesis from the stack. So if you encounter left parenthesis, we look into the stack. If any operator is there, we keep on popping the operator and add it to the B, and also we remove the right parenthesis from the stack. And whatever the result you are getting, you need to reverse that result to get your prefix form. So you have observed that this is very much similar to the postfix expression. The two things we need to keep in mind, that one is this, when we have to pop the operator whenever any operator is encountered, and the second thing is whatever the result you get at the last, you need to just reverse it to get your prefix format. So now we will apply this algorithm to one numerical or one expression to see that how it works. So let's apply our algorithm of converting from infix to prefix to this expression. We want to get our expression as a prefix, we are putting as a b. So the first step says push the right into the stack. So we'll push this into the stack and add the left into the start of the expression a. Now a is our infix expression which is given to us, and we want to get the expression b which is prefix. So we have to put the left parenthesis at the start of this. Now we have to scan from the right to left. So we are going to scan the entire expression from right to left. We read character by character and we will perform the steps which is given in the algorithm. So we read first is 2. So when you read 2, whenever you read the operand, it is directly added to the expression. So it will be going to add it here. Then you read division. So whenever any operator is encountered, you need to push it into the stack. But before you push, you need to check is any operator existing in the stack which is of higher precedence than the operator which you are scanning. Then you need to pop that and add it to the B. So currently we don't have any operator existing in the stack. We simply push it into the stack. Then we read 9. So when you read 9, it will simply add it to the expression B, and there is no change in the stack. Then you read plus. So when you read plus, you will look to the stack. If there is any operator, you need to pop. Yes, so division is a operator which is of higher precedence than plus. So you simply pop this and add it to the expression B and push this operator plus here. Then 4. This is simply added to the expression B, and then you read minus. Now when you read minus, you need to look to the stack. Now there is a difference. When we are working to convert infix to postfix, we also pop the operator which is of equal precedence or higher precedence. But here we will only pop if the precedence is more than the operator which you are reading. So plus is not of more precedence. So we are simply pushing this into the stack and not popping this from the stack and adding it to the B. Then reading next, which is 3, which is directly going to add to the expression B. Then multiply. So when you uh, read the multiplication, then you need to look to the stack. If you find any operator of high precedence, we don't have any operator of high precedence, simply push into the stack, and this remains the same. There is no change in the expression B. Then you read 7. 7 is going to add it in the expression. Then you read division. Now when you read division, you need to look into the stack. Again, there is no operator which is of higher precedence than division, so you simply going to push into the stack. Then you read 14. So 14 is going to add it directly to the expression. And then you read this left. So when you read left, you need to pop all the operators until you find the right parenthesis and then remove the right parenthesis. So you need to pop all this. As we know, this is a stack. So the element which is existing at the top will be popped first. So we are popping all these items. We are going to pop all these operators and adding to the expression B. So what you will get? You will get 2, 9, divide 4, 3, 7, 14, and then you pop this. You will get divide. Then you will get multiply, then minus, and then plus. Now this we have applied all these steps, and the last step is reverse the B to get the prefix. So you are going to reverse this. So when you reverse it, you will get plus, minus, into, divide, 14, 7, 3, 4, divide, 9, 2. So this is our final expression, and this is a desired prefix expression that we get out of the infix. So this is our answer.